Came back in. Next presentation I'm very excited about. These are our gentlemen from Kansai Power in Japan. Pi's been spreading across the country a little bit, and they've done a fantastic job. So please welcome, I hope I get these right, Tadahiro Nakazawa and Akira Kozakai. Thank you.
Good afternoon, everyone. Thank you very much for your kind introduction. Today, we are here to present on what we have achieved and what we are working on with Pi system at a thermal power plant. First of all, I would like to express our sincere gratitude to Mr. David Thomason and Mr. Teruaki Hagiwara and the organizer of this conference for giving us this great opportunity, same as last year. Thank you very much. We Kansai Electric Power are the first power company in Japan to have the Pi system installed at thermal power plant, and we are utilizing it for improving and optimizing operation and maintenance in an organized manner. In this presentation, we would like to show you our more advanced example of using the Pi system than those presented last year, as well as new value-added services for our customers with the Pi system. Here is today's agenda. First, we will talk about overview and business environment of Kansai Electric Power. Secondly, we will show you some good example of use of the Pi system succeeding in improving operation and maintenance at our power plant. Thirdly, we will brief you on a new system which is currently under development as optimizer of power plant operation using AI. And finally, we will talk about our engineering solution services for Japanese and overseas producer, especially among them our remote monitoring service for power plant using the Pi system. To begin with, I will give you an overview and business environment of our company. This slide shows general information of our company. Kansai Electric Power was established in 1951 and is the second largest power company in Japan. Our main service area is the Kansai region, a western part of Japan. In fiscal 2016, we sold about 120 terawatt hours of power, and our total generation capacity is about 37 gigawatt, including a thermal power capacity of 19 gigawatt. When it comes to thermal power plants, we have 9 power plants in the Kansai region, which consist of 1 coal-fired plant, 3 oil-fired plant, 2 gas-fired plant, and 3 gas turbine combined cycle power plant. This figure shows our overseas IPP project. We have recently been expanding our overseas business mainly in Southeast Asia and the United States. The latest project is the Hickory Run Power Station, which is under construction as a gas turbine combined cycle power plant with a capacity of 1,000 megawatt located in Pennsylvania, the United States. We've gotten 30% share of the power station. Next, I will talk about the business environment in power sector in Japan. After Great East Japan earthquake in 2011, the large-scale regulatory reform of the Japanese power sector is underway, following the long-term suspension of almost all nuclear power plants. The reform allows all the users to freely select the power providers and also encourage the new market entrants, promoting a competition in order to lower tariff. This has opened up a market valued at about $200 billion, and the competition has heated up in Japan. Here, we show you our business growth vectors in a new business environment in Japan. First, we optimize the operation and maintenance for our 9 existing power plants to be more competitive in the power market in Japan. Then, we create new value-added services based on our expertise, knowledge, and know-how, which we have acquired through many years' experience in power generation business. And we provide new customers in Japan and overseas with the created new services. In other part of the strategy, we are using the digital technology like a PI system, AI, and IoT technologies. From now on, we will present you about what we have achieved and what we are working on with the PI system.
First of all, we would like to introduce what we achieved at our thermal power plants with the PI system to be more competitive in the market, as indicated in the blue part. Here, we describe how we put in the PI system. In 2016, we had it installed at 3 power plants, which are coal, oil, and GTCC plants on a trial basis. At the 3 plants, about 100 employees from maintenance engineers and plant operators were involved and spent 4 months to create over 200 surveillance displays for better monitoring on key facilities. Then, since we had confirmed the benefits of use of the PI system, we installed it to our all power plants last year. When introducing the PI system, we set up a special team consisting of 6 or 7 employees at each power plant to organize the data tags using the asset framework and create a number of monitoring and management displays for important facilities. In addition, by setting up an information sharing site about the PI system, we are sharing good practices and know-how on the utilization of the PI system so that the power station staff are able to use the PI system more smartly and efficiently. We have 3 main challenges in the operation and maintenance of thermal power plant facilities. The first is to maintain operation at high plant thermal efficiency. The second is to maximize availability of the facilities. And the third is to optimize maintenance, such as expanding the adoption of CBM processes. In order to address these issues, it is necessary to gather and analyze the operating data, visualize the soundness and reliability of the facilities accurately and in real time. And we need to respond in a proper and timely manner. The PI system, which enables the collection, storage, and the visualization of enormous amounts of data, is an essential data management system for our solution. From the next slide, we will show you some good examples in actual use case at our power plants. This slide shows an example for intensive monitoring of boiler tube failures to reduce unplanned downtime and improve plant availability. Boiler tube failures are the leading cause of downtime for steam power plant. But by detecting the leaks earlier, it is possible to prevent the expansion of the range to be repaired and to plan the repair work at best possible time that results in reduction in plant downtime. As you can see, we can monitor boiler water balance in the figure on the upper right and monitor exact amount of boiler makeup water flow in the figure on the lower right. And we can find out any symptom of tube failures earlier than before. This slide shows the PI system use case to achieve availability improvement. In gas turbine, inlet guide vanes, or IGVs, are installed at the inlet of the compressor. Regarding these vanes, we experienced troubles that the vanes became slow in operation at a plant and led to plant shutdown. So we have created these displays to focus on the vanes. As you can see, we can monitor multiple parameters related to the vane operation at the same time on the predictive monitoring display. And we can find out any abnormal symptom of the vanes. And if trouble happens, we can quickly respond to it by utilizing well-organized information related to the vanes, like past troubles information. Regarding inspection and replacements of equipment of forced draft fan, we made them based on TBM before. But with the PI system, we can calculate the actual operating hours of each equipment and visualize remaining lifetime for inspection and replacement, as well as the relevant parameters of the equipment in the same displays. Then we can estimate the time to reach the end of equipment life, and we can prepare a proper maintenance plan based on CBM without any omissions. Here is an example of performance monitoring displays in which we are trying to optimize the boiler performance using the enthalpy function in the asset framework. In this display, we have visualized the boiler efficiency and then the heat balance at each heat exchanger of the boiler, so that we can find out where heat transfer performances are deteriorated. So we can identify the cause of decrease in boiler efficiency and make a proper inspection plan focusing on a part of the boiler. And also, we can use soot blowers to proper points at the best time to improve the boiler efficiencies. Here is an example which we are trying to optimize spray water injection control of HRSC superheater attemperator. Normally, we use the temperature of superheated steam for spray water valve control, but we experienced troubles like delay in control caused by flow characteristic deviation of design specifications and actual one. To tackle with the issue, by utilizing the enthalpy function in the asset framework, we were able to visualize the enthalpy of the high-pressure steam during the operation of the spray water control valve in real time. In the near future, we'd like to optimize the spray water control by utilizing the steam enthalpy and gas turbine exhaust gas temperature and so on. Then we would like to further improve plant efficiency. This table shows the items of cost savings at our ZDCC power plants due to data visualization and data utilization using the PI system. We have estimated reducing cost, reducing total fuel and maintenance cost by approximately $3 million annually. We believe that it will be possible to further improve the O&M efficiency by improving the accuracy of data analysis, and we would like to further reduce costs in the future.
Until now, we presented a case example that we have successfully improved operation and maintenance at our power plant by using a PI system. From now on, we would like to brief you on our new service development using operational data collected by the PI system. We signed an MOU with the MHPS for development of a system using AI to realize the most efficient power plant operation. In this project, we are building the digital twin of our coal-fired plant using AI like a deep learning and machine learning with operating data collected with a PI system. Then, in a digital twin, we can evaluate the optimal operating parameters to reflect the core properties and other conditions and apply the result to the actual power plant for optimizing its operation. We are planning to proceed with this project to apply it to our power plant this year. After that, we would like to promote this system to Japanese and overseas power producers as an optional support service for their better power plant operation. Next, I would like to talk about our value creation services based on our expertise and operational know-how. KVAX is a brand name for our engineering and solution services. It is an acronym for Kansai Value Creation Service, which utilizes our knowledge and know-how on the power plant operation and maintenance, as well as tools and templates we have created over many years of power generation business. We would like to provide Japanese and overseas power producers with engineering and solution services at all stages of power plant life cycle. In other words, we can offer the services to carry out feasibility study, front-end engineering and design, construction management, and support for operation and maintenance, and so forth. Next, I will present our remote monitoring service for power plant, which is one of the KVAX with the PI system. This photo shows the remote monitoring center, our head office. We set up the center and launched a remote monitoring service last September. We have 4 expert operators there and have installed the PI system and anomaly analytics software into the computer at the center. The center collects the operating data from the power plant overseas via the internet on a 24/7 basis. At present, our remote monitoring center supports a coal-fired power plant in Western Australia. In this service, we have created more than 50 monitoring displays with the PI system based on our know-how on monitoring operating data and performance data. Also, we have developed some early anomaly detection models with the analytics software using machine learning. We have the software learn the normal and abnormal operating data at the plant so that the software can detect anomaly earlier and more accurately than operators. When there are any symptoms of abnormality, our remote monitoring center advises the plant operators on what to do to prevent any troubles in advance. That contributes their improvement of KPI, such as the forced outage rate and the plant availability. Today, we, Kansai Electric Power and OSI Soft, signed an MOU and issued a press release in Japan and in the United States, respectively. This MOU and press release is about collaboration between Kansai Electric Power and the OSI Soft for adoption of the PI system. OSI Soft installs the PI system and provides product training and customer support, and Kansai Electric Power provides PI system adoption support as one of the KVAX, such as a consulting service for introduction, preparation of surveillance displays, and creation of anomaly detection models. Based on our experience and know-how and knowledge about the PI system and power plant operation, we can contribute to the benefit of the customers, such as efficient operation, high availability, and maintenance cost reduction, and so on. From now on, we would like to enhance the collaboration with the OSI soft and promote adoption of the PI system and our KBACs. Finally, I will present a summary. With the PI system, we have successfully enhanced competitiveness of our power plant, and we are developing some value-added services with the combination of our operational know-how, expertise, and digital technology. One of our plants has estimated fuel and maintenance cost saving by around $3 million per year. We are expecting nearly equal amount of cost saving in coal-fired power plant and other GTCC power plant. And we would like to widely promote our new services to increase our sales in the future with the PI system. Thank you very much for your attention.
Awesome job, guys. Thank you so much. We have any questions for the gentleman from Kansai? Come on, lunch wasn't that heavy. Maybe it was. I don't know. Hang on just a second. We'll get the microphone.
Wonderful presentation. I had a question about combining the PI system with the big data tool. I saw it on a slide. Did you have any, what sort of tool is that, and what do you use it for? And if you could tell us some challenges that you experience combining them two.
Okay, so PI system is about PI system. It is easy to install at the site, so that's why we didn't have not so big challenges to combine PI system and big data, but at the stage of installation. But now, so of course we are trying to improve the quality of a remote monitoring service. So such as anomaly detection. So we have a big data, and based on the big data, we are now making an anomaly detection model and improving quality of a model. But of course, we improve the quality of a model and remote monitoring. So, but still, we are trying to improve and struggling to make it make it good. So surprise the customer with good service.
I think maybe the next step is going to be try the integrators to big data, from PI to big data systems.
Thank you for this presentation. It's very good. The question I have is, how did you integrate your PI system with the digital twin?
Okay, so we are making data twin based on collected data with the PI system. So using collected data with the PI system, we are making data twin. So data twin means virtual power plant. So virtual power plant means the model which simulate the movement of a boiler virtually on the computer. So on that model, so we change the parameter and the input data of the boiler on a condition boiler. So we check the performance at each condition. So that's why we can seek for the optimal point of a boiler operation. So it is a digital twin by using collected data with a PI system.
Any more questions? All right. Gentlemen, thank you so much.
Dave, one question.
Oh, wait, one more. corner.
Thank you. Excuse me. I'm going to discuss this in Japanese. すみません。MHPS ともにパイ運用チームの木村と申します。リアルタイムで通信されているっていうのを拝見したんですけれども、ちょっと周期、取り込み周期について教えていただくことは可能ですか？
Okay, so her question is how often do we collect the data from the power plant? So we collect the data. So currently, second, 2 seconds, every 2 seconds.
2秒周期。
Yes.
あ、わかりました。ありがとうございます。
We live in a real-time world here. I want the data when it happens, right? Any more questions? Okay, well, thank you so much, gentlemen. We really appreciate it.